for practice exercise 16.11, which is compress, this is a pretty long one. We need to write a method called compress, and it should be added to our LinkedLists class, which we can assume exists down here. It already is coded for us, and it's going to accept an integer n as its parameter, representing a compression factor. So if we have an example like this, and we're passed in list compress 2, well, the first two are going to compress to be together, the next are going to compress to be together, and so on and so forth. Now, there are some rules that we need to comply to. First, the following here. If we have like list.compress 3, it's going to replace every 3 elements with a single element. So these 3 are going to be added together, and then it actually looks like it's doing the example based on this one right here. So these 3 are going to be added together, and then these 3 are going to be added together. It's not another condition, it's just another example. The conditions are really down here. So if the list size is not an even multiple of n, whatever elements are left should just be compressed and add together into the last node. Give us an example here, and if n is greater than or equal to our list size, the entire list compresses into a single element. If the list is empty, the result after the call is empty, regardless of what factor of n is passed in, and we may assume that the value passed in for n is greater than or equal to 1. Let's start coding this. We need a public void, we have compress, and then inside of here we take our int n as parameter. We have our list node current is equal to front, so we are having this list node value equal to the head of our list, so we can start looking at it. Now inside of here we want a while loop, so we can go through our entire list. We want to run this while I believe so far our current does not equal to null. And then inside of here is where we're going to do the compression. So we need to compress this a certain many times and many times. This is perfect for a for loop. So we're going to do for, and then we'll have int a is equal to 1, and I'll show you why when we do a little diagram in a second. And a has to be less than our n, and we just have a plus plus. Now inside of this for loop we are also going to need an if statement. So inside of here we're going to say if, and we want to run this, and this is mostly for the condition right here where we want to make sure that our next value is not null, so we can keep adding it in here. So if our current dot next does not equal to null, we are going to want to add into here. This is currently what we have right now. Based on the example up here, we want to compress these two nodes together. So what we're going to do is set our current data value, so the front value, or current.data. We want to add to it the current.next, which is going to be this value right here. So we want to add these two together, and then we'll do something else after that. So to add them together, it's just current.data plus equals to, and then you're going to have current.next. So you're going to add the next value to the data value. Oh, and I messed up a little bit. Current.next is just the pointer. You need to get the data value. So if you just do current.next, you're just going to get the position, right? You want the actual data value at the node right here. So this is done for that line. Now we're going to have to move our pointer, which is this thing. Typically in previous examples, we've moved it to this next one, so we keep looking at it. But what we want to do here is skip over this because we've already compressed this and look at this next one right here. So we're going to set the current.next, which is going to be this pointer right here. We want to unlink it from this and set it to this one right here. So this right here is current.next currently, and we want to push it to this current.next next. We'll do it by saying current.next is equal to current.next.next, and that's going to give us the pointer right here linked with this. So it's going to go to that next data value. So if we're using the example that was given to us initially, we know that we have these values. We have our front right here, and these are linked together like this. So when we go through this while loop the first time, it's fine because current is not equal to null. We go into this for loop, a is equal to 1. We can go in this one time because a is less than 2, which is our current n, which is what the compression size is. So we want to add the first two together. So we go through here, current.data is equal to current.next.data. So remember, this is current.next. So we're adding these two data values together. So after that call on line 8, it's going to be 6, and then we're going to have 4, 18, 1, and so on and so forth. And these are still going to be linked together like this. Now, we don't want to look at 4 again. So we need to move our current next pointer, which is this one right here. This is still fine pointing at data, right? We need to move this pointer over here. So that's why we say that our current, which is here, dot next, which is pointing to here, is going to be equal to current dot next. So this is the current value, this is the next value, and this is the next value. So that's how that assignment would work. And that is going to be it for that if statement, because that's pretty much it. Once we're done with this, we would go back into our for loop. And if there was, like, let's say that this was 3 instead of just 2. Well, if it was 3 instead of just 2, from here we would go back into this if statement. Current.next is not equal to null, right? Because our current.next value, this pointer right here, is now equal to 18. So we can go inside of our if statement and say our current.data plus equals our current.next.data, which is now this value because we reassign current.next here in the previous iteration of that loop. So we would have 6 plus 18. That's pretty much it. And then we would just move the next pointer over to this one. So that should be it in our for loop. Now, when we're done with this for loop, I'm going to go back to when we had 2 as our example. Our current pointer, which is still pointing to the front right here, is in the wrong place, right? It needs to be moved for us to look at the next value. So we need to move it to the current dot next value. Remember, 4 is not in here anymore, so we're going to have 6, 18, and 1 like this. We have this node being linked to this node, and then this node being linked to this node, and then our current front is pointing to the 6. We want to move it 1 over, so now we can start looking at this 18. So from here, we're just going to set our current, which is here, equal to current dot next. That way that we're not looking at this anymore. We're going to move past it. This is good now, and look at this part right here. What this looks like in our code is current is equal to current dot next. We would end this line, and that would actually conclude our while loop, and that would conclude our method. This completely runs through our entire list. If I scroll down, you'll see some other code here. Check out that next video in the playlist link below the like button to see how to do this recursively. It's a bit of a skill, it's a bit of hard work, but if you're able to understand it, it's pretty cool. Anyways, the normal solution will pass 7 out of 7 tests, and that's going to be it for our 16.11 compress.